Today we finish the OOP package with 3 classes: polymorphism, abstract classes, and interfaces. These are the concepts that turn Java into an architecture tool. Polymorphism means many forms. The same method call behaves differently depending on the actual object type at runtime. We start with an abstract shape class, a color field, 2 abstract methods area, perimeter, and a concrete describe that calls them. 3 subclasses follow: circle, rectangle, triangle, each with its own formulas. Same signatures, completely different math. The key demonstration: a list holding a circle, a rectangle, and a triangle. We loop through calling s.describe. The variable s is always type shape, but at runtime describe internally calls area and perimeter, and those dispatch to the real subclass. 1 line of code, 3 different outputs. This is dynamic dispatch. The JVM follows the object's internal class reference to find the correct method at runtime. The power: add a pentagon later and the loop never changes. Code written against the abstraction shape works with any future subclass. We also show compile time polymorphism through overloading. MathUtils has 4 add methods: 2 integers, 2 doubles, 3 integers, 2 strings. The compiler picks the right version based on argument types before the program runs. Same name, different parameter lists, resolved at compile time, distinct from overriding but equally polymorphic. The upcasting and downcasting section closes the demo. Assigning a circle to a shape variable is an implicit upcast, safe, always allowed. To access circle-specific members like radius, you downcast with instanceif pattern matching, which checks the type and extracts the variable in one safe operation. An abstract class sits between a concrete class and an interface. It can have fields, constructors, shared implemented methods, and abstract methods that subclasses are forced to define. The abstract keyword on the class prevents new animal entirely. Our animal base class has name and species fields set via constructor, a private energy tracker, and 3 abstract methods: make sound, move, energy cost per action. These have no body, just a semicolon. Subclasses must implement all 3. The shared concrete methods are where the elegance lives. Eat restores energy. Sleep fully recharges it. And act calls make sound, and move, the abstract methods. The abstract class invokes methods it doesn't implement. This is the template method pattern built into the language. The algorithm skeleton, reduce energy, emit sound, perform action, is defined once. The specific steps are delegated to each subclass. 3 animals follow. Dog says, woof, runs, costs 10 energy. Bird says, tweet, flies, costs 5. Fish says, blub, swims, costs 2. Each subclass is minimal, only the abstract methods need code. Everything else is inherited without duplication. The guideline: use abstract classes when subclasses share state, fields, and partial behavior. Use interfaces when you only need to define a contract with no shared state. An interface is a pure contract, what a class can do, not how. A class can implement multiple interfaces, giving Java safe multiple inheritance of behavior without state collisions. We define 3 interfaces. Printable has print plus a default print uppercase. Savable has save with a default get format returning unknown. Drawable has draw and a static factory no-op, returning a lambda. Default methods, added in Java 8, let interfaces evolve without breaking existing implementations. Static methods on interfaces attach utilities directly to the contract. At functional interface on transformer enforces a compile time rule, exactly 1 abstract method. If someone adds a second, the compiler catches it. This is the foundation of Java's lambda support. Any functional interface can be implemented as a concise arrow expression. Document implements 3 interfaces at once. It provides all abstract methods and overrides the default get format to return PDF. Classes that don't override it still get unknown. We then show interfaces as polymorphic types. A list holds document objects, and calling print on each dispatches correctly. The functional interface demo uses transformer as a lambda target. str-str length takes a string and returns its length. N-repeat, n, takes a number and returns asterisks. No boilerplate, no anonymous class, just the contract implemented inline. Finally, interface inheritance. Shape3D extends Shape2D, adding volume and overriding describe. A sphere implements Shape3D and provides both area and volume. A square only needs Shape2D and only provides area. Any Shape3D is also a Shape2D, so you can use a sphere wherever a Shape2D is expected. The OOP package is done. 5 classes covering encapsulation, inheritance, polymorphism, abstract classes, and interfaces. These aren't just interview vocabulary. They're the structural principles that let you build systems that grow without collapsing. Next episode we shift to the collections package, list, set, map, queue, sorting, searching, and the performance characteristics that dictate which collection to choose. See you in episode 5.